Good morning everyone. Again, maraming salamat po ulit sa pagsama sa amin ngayong umaga para po sa isang free webinar ulit about nanotechnology. Next slide please, Kuya JP. All right, so before we start with our webinar, let me just give some pointers. Please mute your device's microphone, keep your cameras turned off while we are doing our webinar. And please reserve your questions toward the end of the presentation. And you may send your questions by the Zoom chat box or YouTube live comments section. So para po sa mga nasa YouTube, pwede po rin kayong magtanong. And please don't record this webinar using your personal gadgets or your laptops. Next slide po. So after the presentation, we will have a question and answer portion that is 30 minutes after the lecture. And certificates will be issued to Zoom and YouTube participants who are FilSciHub followers. And the Google form link will be posted on Zoom chat box and YouTube live comment section. And finally, slides will not be shared, but the web lecture video will be uploaded on YouTube and Facebook and also in our website. Next slide, please. To introduce our organization, can I call on Mr. Ralph Alomia to introduce the Filipino Science Hub?
Ayan, good morning everyone. Thank you very much, Marty. And let me introduce to you the Filipino Science Hub. So the Filipino Science Hub, formerly the Batangas City Science Teachers Hub, was founded by Dr. Jeffrey Bunkin in 2012. So this serves as an online platform that promotes science and technology, engineering and mathematics culture among elementary and high school students in the Philippines. So its mission is to help strengthen the STEM literacy in the Philippines by advancing the competencies of Filipino teachers. So the Filipino Science Hub also envisions this platform to facilitate exchange among STEM teachers, students, and Filipino scientists, subject matter experts from around the globe. So our team is composed of scientists and teachers in the US and Laguna. So let me introduce to you the members of the leadership team. So we have our founder, Dr. Jeffrey Bunkin, the head of research. We have Mr. JP Onya, the head of contents and creatives. We have Mr. John Marty Mateo. And then head of communication and external affairs, we have Dr. Janice Averilla. And then head of educational extension programs, Dr. May Joan B. Aguila. And then the head of business affairs and yours truly. Okay, so be part of the FilSciHub community by following or liking our Facebook and YouTube pages. So you may also visit our website. Next slide yata ito. Ayan. So we have our website www.filscihub.com. So in that website, you can see learning materials that will help you to facilitate your classes. So we have the compiled modules in our website. And also, you may follow our social networking sites. So we have our Facebook page, and then we have YouTube, Instagram, Twitter, and then we also have TikTok, TikTok page wherein you can see our educational videos. So thank you, Marty.
Thank you, Ralph, for introducing our organization. And For today, we will be discussing about nanotechnology, and our speaker will talk about trends, tools, and techniques, specifically with the scanning electron microscope, atomic force microscopy, and dispersive X-ray microscopy, or EDS. Next slide, please, Kuya JP. So our speaker for today is Engineer Marlon Liana. He is the Technical Director of NASAT Labs. He completed his BS and MS in Chemical Engineering from Mapua Institute of Technology, and also a PhD candidate in Material Science and Engineering. He has 20 years experience in semiconductor industry and a technical assessor of DTI-PAB for ISO IEC 17025-2017. So wait lang po natin ulit pag-appear yung slide. Parang nawala. Kuya JP.
Sorry.
Ayan. And also, he is a former officer of the Council for Failure Analysis and Reliability, or CFAR, and also a former faculty member at the Malayan College Laguna and Lyceum of the Philippines Laguna, and also in Colegio de San Juan de Letran. So without further ado, may I call on Engineer Marlon Liana to give this webinar. Sir?
Hello, good morning.
Morning po.
Good morning, everyone who are listening to me. I hope you're doing okay wherever you are. So let me open up my file. All right. So can you see my file before I start?
Yes, sir.
Okay.
Yes po.
Hold on. Okay. So again, good morning. Thank you for joining this today's webinar. It's a Saturday. We actually rescheduled it for today instead of last week because we understood that there was a typhoon in the Philippines. So I'm not sure that those who supposedly understood that it will be held on November 21 are still here. I'm sorry for the rescheduling. We made that decisions for all of you. So what do we expect from this webinar? I'd like to first show you our company profile, who we are and what we do. Maybe we can help you with your research. I understand from the presentation of FilSciHub that they are supporting the STEM educations of the Philippines. So maybe NASAT Labs is a company who does testing and training can support you as well. And then we will go directly with a discussion on nanotechnology, technology and trends. I'm gonna show you the directions of the global directions in terms of technology, and we'll see what the experts say about the directions of technology. So we call it the technology paradigm, and I'm gonna show you the potential market value of nanotechnology. So one day, if you are a student right now and listening to me, if you engage to nanotechnology, you will realize that once you engage in nanotechnology, you will have a very bright future. Then I'll show you an example of nanotechnology in real life applications, things that's happening today, products that are already in nanotechnology, research in nanotechnology concepts. And then we'll end up with the presentation on scanning electron microscope and atomic force microscope, two of the tools that are commonly used in nanotechnology research. So NASAT Labs stands for Nanotech Analytical Services and Training. So it's an acronym. So it sounds like NASA with the letter T. So the name itself says that it's testing and training. So we can offer you that once you have a need to do research, particularly on nanotechnology. So these are the things we do. We do failure analysis and material characterizations. Initially, when we started in 2009, we served the semiconductor and electronics because they were the ones who are honestly the first who were engaged in nanotechnology. And since the instruments in nanotechnology are quite expensive, so they were the ones who are our regular customers. So when we started in 2009, we targeted them. And then later on, we expanded our reach, including the academia. And then recently, we added water and environmental testing capability. That's another location. I will show you the lab. And then we're also offering consultation services. Oftentimes, if you know me, you'll find me in different places, in different companies, attending their meetings, doing some consultation services for them, participating in technical discussions. And a lot of times, I also do technical trainings with actual demonstrations. I must admit that most of my technical trainings are, with corresponding professional fee. When we started this, we serve the industry because the industry needs a lot of technical trainings that usually can only be attended in outside the country. But with NASAT Labs, these trainings are now available to them without flying abroad. I also do lots of scientific talks to various universities and organizations across and over the Philippines per invitations. And oftentimes, you'll see me being a speaker to University of the Philippines, Ateneo, and many other universities that are near national capital regions and Calabar zone. We also have some research collaborations with industry. We have some MOU, MOA with certain industries. We have the tool, they have the idea. So together we bring the idea into the marketplace. And then we have some immersion programs, not only for students, but also for professors. So this is one of the things that we are proud of. We, in terms of supporting the STEM educations. So we encourage all the professors to one day, once the pandemic ends up, to visit our lab, and if they want to be immersed to actual instrumentations involving nanotechnology, then I'll tell you that you're always and will be welcome to the laboratory. And then we also accept educational tours. Not today, not this season, but before the pandemic, uh, educational tours are our routine. So this is the pictures of the laboratory in our Muntinlupa facility. So we call it the failure analysis and material characterizations laboratory. So you'll see some of the instruments we have here. We have the scanning electron microscope. We have the thermal emissions OBERT for semiconductor companies. And we have other tools like thermal analysis, like differential scanning calorimeters. We have the AFM. And this is the facility in in Cabuyao. So we call it the Water and Environmental Lab. So not the entire building. So we're neighbor to Malayan College. So the ground floor is where our laboratory is. The inside of it, you'll find the atomic absorption spectrometer, the ICP-OES, This is used typically for metal analysis of water samples. And we have the UBVIS, we have the static light scattering machines for particle size analysis of 500 microns and above. And we have a room for microbio. And of course, we have the simple testings like titrations used for COD and BOD analysis. Many other things that you can find at Kabuya facility. Oftentimes, students and professors also come here to to do their research on their theses. In here slide, I picked examples of the training courses that we offer to the industry. If you want to see the entire listings of courses, you can visit our website, and you'll see the uh, descriptions of the course. And some of these training courses have corresponding CPD points for chemical engineering and chemist graduates. So in case you wanted to renew your license after 3 years, and NASAT being a training company, we are also an accredited CPT provider by the Professional Regulatory Commission. Um, Showing here some of the pictures of the previous trainings and workshops that we did at our facility, sometimes outside NASAT Labs, like the picture on the bottom far right. We did it at the International Rice Research Institute, where we did a workshops on photosynthesis measurements. And scientific talks, per invitations, and sometimes we organize it ourselves. Like in this case, we invited many scientists and seasoned speakers from different countries such as U.S., Japan, Taiwan, Australia. We organize it in Alabang. By the way, our Muntinlupa facility, in case you're listening to me and you're from other parts of the country, Muntinlupa is about 20 to 30 minutes from Manila Airport. And the Cabuyao facility is another 20 to 30 minutes from Muntinlupa. So via Skyway, so it's easier to get here. All you need to do is, probably take a taxi. You can also commute by bus. And these are the images of the educational tours and some immersion programs that we did in the past to support professors. Even the individuals who wanted to search for careers outside the country, who are not actually teachers, not even students, but already professionals, are seeking the chances and opportunity to have the immersion programs provided by NASAT Labs. Now, let me start formally with the discussions on nanotechnology, technology, and trends. You can reserve your questions after the discussions. I understand that Marty, our facilitator, will be doing facilitate the question and answers for you. Now, I don't know if you have seen this technology paradigm. This technology paradigm is released by Merrill Lynch. And Merrill Lynch is a financial service company of Bank of America. They are a subsidiary of Bank of America. They have more than 17,000 financial advisors. So what Merrill Lynch do is they study the different technologies of the world, and they created this sort of a chart. And X coordinate talks about the year when it started, the technology when it started, and then the year when it was finally adopted by humanities. So that means this year, red dots represents the rapid adoptions where the technology becomes part of our daily lives. And the blue ones are technologies that are considered mature. So like textile, railway, automobile, computers. And the red curve is the artificial intelligence. This is expected still to mature by 2061. But my topic for today is the green curve. So this is the nanotechnology. And if you can see this slide, the expected maturity of nanotechnology is still by year 2081. So there's still long way to go. So many years. So if you are still students, you have, all I'm saying is you have a very bright future for you if you align yourselves to nanotechnology. And if you are researchers or probably masters and PhD students, maybe some of you are already utilizing nanotechnology tools. And I say that you're doing it right, um, and you will benefit from aligning your careers to nanotechnology. Now, let us look at the different industries crossing the nano zone. I started my career in semiconductor. I have more than 20 years experience with them. And I witnessed that they were the ones who actually the first to engage in nanotechnology. There are many nanotechnology instruments that they were the ones who are first users. So semiconductors and electronics are ahead in terms of nanotechnology. And then the rest of the industry, like materials, development, and pharmaceuticals, are now also crossing the nano zone. And let's look at the market value of nanotechnology worldwide in terms of $1 billion. So this chart, it comes from Statista, released in 2020, and you'll see that the market value of nanotechnology worldwide is continuously increasing. And this 2019, 2020, it reaches to more than 50 billion US dollars. And here's the breakdown of nanotechnology R&D expenditures in business sector from 2016 to 2018. And obviously, this chart shows that the United States of America, the USA, is leading the trend. They have, the business sectors from the US have spent more than $18 billion already. And then the rest of the other countries from Europe, some parts of Asia, are also now beginning to spend in terms of nanotechnology. And this is the chart for expenditures in nanotechnology for educations in the government sector. So you may not see US and maybe China, but there are some countries who doesn't have the data, but it doesn't mean that their governments are not spending on nanotechnology. You can see that Russia, for example, the governments of them are spending 791 million US dollars for nanotechnology research. Now, in the Philippines, since I'm a member of the technical committee for nanotechnology, I know that the Philippine governments are giving a lot of funding to the Department of Science and Technology, and then the Department of Science and Technology are also giving away funding to support many research. Although not only nanotechnology, but a lot of the research that they have funded are related to nanotechnology. So the Philippines and Philippine University are now slowly, investing or putting a lot of resources on nanotechnology. So this is the global nanotechnology market forecast. So by 2024, it's about 125 billion US dollars. And that is distributed to electronics, to energy, biomedical, cosmetics, defense, automotive. So it's not only about electronics. Even cosmetics has a lot of nanotechnology applications. And healthcare. So this is a very important industry right now, the healthcare. And the healthcare markets are now growing. And in fact, they're actually spending, and they have more bigger projections in terms of market value. And these are some of the healthcare companies that are considered to be key players in terms of nanotechnology. So let us read some of projections for the global healthcare nanotechnology market. So by 2027, the forecast on global healthcare nanotechnology is to reach 475 billion US dollars. That's a lot of money, almost half a trillion dollars already. So even this COVID time, the current value of healthcare nanotechnology is 183 billion US dollars, with an annual growth rate of 14.5% over 2027 timeframe. And in the US, the nanomedicine market is about $54.3 billion by 2020. And China is even bigger than in probably in the US in terms of projections, which is about $83 billion by 2027, giving a 14% annual growth rate, between 2020 to 2027. And other countries like Japan and Canada are also, giving significant growth rate, they 12 around 12%, 13%. So, after giving you that idea of how big nanotechnology can be, so allow me to give you a little bit of introductions on what nanotechnology really, what's really it's all about. When we say nanotechnology, it's actually talking about dimensions. And the dimensions, according to ISO, nanotechnology is between 1 to 100 nanometers. And that dimension is defined as the nanoscale. So this diagram below is the length scale, just to give you an idea. So D is 15 millimeters, so it's okay. The eyes can see it. Our hair, 60 to 100 microns. Actually, my hair is microscope. The virus, the coronavirus is around 75 to 100 nanometers. So that's already a nanotechnology, um, nano material. And the DNA is around 2 nanometers. And why do we have to consider nanoscale? The very simple reason is that there are a lot of properties that are dependent on dimensions, or nano dimensions. And I attach here an example of a solutions in which the color changes as we change the increment of cadmium selenium in the solutions by 1 nanometer. So a very simple illustrations, yet a very powerful way to illustrate the influence of nanoscale in terms of an observable physical property. So it changes solutions, the color of the solution changes just by a 1 nanometer increment of cadmium selenium. And there are other properties that are highly dependent on nano dimensions, including electronic properties, magnetic properties, chemical properties, strength, frictions, and adhesions, and many more. Now, let me show you an example of products today that are already available in the markets that were developed using nanotechnology. Maybe some of these are already familiar to you, but you don't know that it's already nanotechnology. One is sunscreen. So I'm sure you're familiar with sunscreen. And sunscreen contains, two particles, titanium dioxide and zinc oxide. So they protect us from ultraviolet rays, which are considered harmful to our skin. And the image on this slide is the image of zinc oxide taken using scanning electron microscope at 100,000 times magnification. Another important product in nanotechnology is the paint. So I think years ago, Boysen Pacific Paints, they developed a paint brand called Nax Out. And Nax Out contains nano titanium dioxide that helps protect or clean the air. So it contains this is an image of titanium dioxide taken using 30,000 magnifications by SEM. So they painted some parts of walls in EDSA to demonstrate the effects of nano titanium dioxide, the knocks out paint, in cleaning the pollutants from the vehicles. It's called their air cleaning paint. Another example of products with nanotechnology is the hydrophobic uh, coatings. When we say hydrophobic, it's a water repellent coatings. So let's say you have an expensive Mercedes Benz or BMW, and you'll see their side mirrors. The range doesn't attach to the side mirrors because they are with hydrophobic coatings. So this is an image of how the hydrophobic coatings are preventing the rains from attaching to the surface of the glass. Now let's go to the Philippine applications. Fertilizers, very important to the Philippines because we're still considered an agricultural country, and many um, real estates are now being converted into subdivisions. Many agricultural lands are being converted into housing projects. So the importance of nano fertilizers are in terms of improving the yield without the need for large area of soil where we can plant vegetables and important crops. And I know two universities in the Philippines that are producing nano fertilizers. And one of them is the Central Luzon State University, and the other one is University of the Philippines, Los Baños. So this technology that's very useful for agriculture is important in the Philippines. Another local example of nanotechnology is this one, very timely this COVID season. This is called the nano enhanced hand sanitizers. It was, I'd like to take credit for Dr. Jovi Monserrate. He is a professor of Central Luzon State University. He develops the nano enhanced hand sanitizers. It's not yet for sale, but he donated it to different clinics and hospitals within Nueva Ecija. So the reason why it's yellowish is because he extracted nanoparticles from luyang dilaw, no? So it's turmeric. Another product, maybe I don't know if you're already familiar with when you visit the mall and you wanted to, protect your gadget from scratches. Usually we buy a film, and today we already have an equivalent liquid coatings. No? So it's called a scratch resistance nano coating from NanoFixit. NanoFixit is a foreign company, but they have the presence in the Philippines. They one time they went visited NASAT Labs to look at how the nano coating looks like using the electron microscope. So there are many tools for nanotechnology. I'm sure you probably think of how much, but I'm telling you, most of them are expensive, but there is a solution if you don't have the resources to buy them. No, so we have third party laboratory, we have FilSciHub, we have NASAT Labs to help you find you can send your samples for nano characterizations. So these are some of the list of instruments for nanotechnology, like scanning electron microscope, transmission electron microscope, EDS, WDS, electron backscatter diffractions, DLS, scanning probe microscope. These two are not only for nanotechnology, but these are for polymer characterizations, which oftentimes used for nanotechnology as well. And then the OJ electron microscope. But for today, because of limited time frame, I'm going to show you two instruments: scanning electron microscope and the atomic force microscope. So let me begin with scanning electron microscope, or SEM or SEM. Now, SEM or SEM, scanning electron microscope, is still a microscope. And when we talk about microscope, we are most familiar with optical or light microscope. So the reason it's called optical is because it utilizes a light as a source, such as this image of a microscope. The back of this microscope is the halogen lamp, around 100 watts. And since it utilizes light, the image from this microscope is a colored image. So the light it has a wavelength of 400 to 700 nanometers. And what you see is just if you're using a reflected microscope, it utilizes a reflected light from the sample going to the objective lens, to the eyepiece, or to the camera, in case the microscope is equipped with a camera. So the image that is collected from the optical microscope is a colored image, because the reflected light has a corresponding wavelength. So this is an example of an image of a tea leaves. And the optical microscope, since it uses an ordinary light or a visible light, the inside of this column is an ordinary mirrors and lenses. You can easily analyze or observe samples just by placing your samples or specimen onto the stage, without much of a preparations. You don't need a vacuum. So it's a very simple instrument to observe your specimen. The only disadvantage to an optical microscope is that it's limited in terms of resolution. So it's not really an instrument for nanotechnology. Another type of microscope that may or you may not be familiar with is the acoustic microscope. Now, if the light microscope or optical microscope uses light, the acoustic microscope uses sound waves, particularly the sound waves with ultrasonic frequency. When we say ultrasonic, the frequency of sound waves here is about 5 megahertz and above. So maybe the most familiar acoustic microscope to you is the ultrasound, used for imaging the baby inside the mother's tummy, or imaging your kidney or your gallbladder. It's an acoustic microscope. The probe there is called the transducer probe, is about 5 megahertz frequency. The disadvantage of a megahertz frequency is that it can only travel on a liquid medium. Unlike a kilohertz frequency called a radio frequency, which travels in air, a megahertz frequency can only travel in a liquid medium. So this is the reason why when you are being ultrasound, the radiologist place some liquid gel onto the surface of the skin. That liquid gel is not a lubricant, not only as a lubricant, but it also serves as a path for the propagations of ultrasonic frequency from the probe to the inside of your body. So it's called the ultrasound. But in the semiconductor, we have an instrument called the scanning acoustic microscope. Similar to the ultrasound, it uses a transducer probe that's immersed in water. And because of these transducer probe, we're able to image the inside of a semiconductor device without physically opening it. similar to the concept of looking at the inside of the tummy without physically opening the tummy. So yeah, that's called the scanning acoustic microscope. Another type of microscope is called the X-ray microscope, and you're familiar to it. When you go to the airport, your luggage is inspected by security, and they're looking at the inside of your luggage without the need to open your luggage. And in case there are high density materials such as metal, guns, sharp knives inside of the luggage, they'll be able to see it. And X-ray can propagate through air. So that means you don't need to immerse like the ultrasound, you don't need to immerse your luggage in a water. So it's propagated in air. So this is an example of an X-ray instrument used for the semiconductor company. So it can see the inside of an electronic components without physically opening the casing. But our topic for today is about electron microscope, scanning electron microscope, which is a common tool for nanotechnology. So I've shown here two conventional scanning electron microscope. One is a tabletop scanning electron microscope, and the other one is a floor type scanning electron microscope. They're both electron microscope, but they have different capabilities in terms of magnifications. So this one can go over 150,000 times magnification, depending on sample. This one can go about 300,000 times magnifications, depending on sample. So, and this is an example of an image of fiberglass. So what you're seeing here are rods of glass fibers that are embedded on the matrix of a resin, epoxy resin. So that's this scanning electron microscope are using electrons. So if optical microscope is using light as a source, an acoustic microscope is using sound waves, ultrasonic sound waves as a source, and an X-ray microscope is using X-ray as a source. Scanning electron microscope is using electron as a source, and that electron is usually located at the topmost part of the column. So that's where the electrons are coming from, here at the top. So there are another type of scanning of electron microscope is called the transmission electron microscope, TEM. So this is the mode of imaging is different from scanning electron microscope, but I'd like to show you idea. That's me when I was in Japan doing the TEM image of semiconductor samples. So this one is using 300 kilovolts of electron guns, and that passes through a thin specimen, and the transmitted electrons are collected by the phosphor screens and captured by a CCD camera, and that generates a high magnifications image of samples. In the Philippines, most people are familiar with DEM as a tool for uh, medical applications, like looking at cancer research, looking at kidneys of humans and rats. But in material science world, it can also be used for material science. Only that it uses more powerful gun than the TM for medical applications. So why do we have to use electrons for creating a microscope? Why not use other sources? Why not improve optical microscope and make it more powerful than the conventional ones? Why do we need to use electrons? The answer is electrons has a much smaller wavelength. So like these illustrations, imagine these two red dots represents distance between two particles or two objects. Can represent atoms or molecules, or can represent particles. Let's say the distance between the two dots are too small, such that the the wavelength of light is so big to be able to decipher the distance between the two particles. So, but if we use the electrons has much smaller wavelength than the wavelength of light. Now, I'm sure you're familiar. The wavelength of light is 400 to 700 nanometers. 400 is for violet, 700 is for red. Below 400, that's ultraviolet. Above 700, that's infrared. But even though the 400 wavelength, it doesn't have enough, wavelength to be able to image a very, very small object, especially those that are in nano dimensions or in nanoscale. So this is for the reason why we use electrons as a source. So this is how the image is generated using the scanning electron microscope. This is the gun. That is the top. Sorry, let me go back. So this is the gun called the electron gun. It contains a filament. So in this case, it's made of tungsten filament. Tungsten is a very good, filament because the melting point of tungsten is over 3,400 degrees Celsius. So even if you apply large amount of voltage or you heat tungsten, tungsten won't easily melt. So once you apply voltage to the tungsten, tungsten will generate heat, and the heat will generate lots and lots of electrons. And that electrons are, exiting the gun through this electrode, and these electrons are reduced into smaller diameter and moves across the X and Y. Now, that process of X and Y motion is called rasterizations, also known as scanning. So that's why scanning electron microscope is called scanning electron microscope, because we are, moving the electron beam across the X and Y through these electrostatic lenses. And if going back to optical microscope uses ordinary mirrors and lenses. It simply reflects the light. But electrons cannot be reflected by ordinary mirrors and lenses. So the only way to control the electron beam is by the use of electrical field or magnetic field. And so for these reasons, scanning electron microscope has a specialized design in a sense that they're using electrostatic lenses to generate electrical field. And that electrical field are the one responsible for controlling this electron beam to scan this electron beam on the surface of the sample. So once the electron beam scans the sample generates different types of signals, and that signals are detected by the attached detectors to the instrument. So this is how the outside of a conventional floor type SEM looks like. So you have here the gun, you have the column containing the electrostatic lenses, and you have the detectors attached to it. So these detectors are responsible for detecting multiple types of signals that contains multiple informations about the specimen. So one detector here is scanning electron secondary electron detector, the backscatter electron detector, and one detector here is the X-ray detector. And this X-ray detector is used to analyze or detect or determines the presence of any elements in your specimen, beginning from boron to uranium. So you can see that. So let me summarize the capabilities of an scanning electron microscope. So one is you can use the scanning electron microscope for topographical information. So once you say topographical information, you can see the surface of the object, describe its texture, and correlate that texture to the physical properties of material. So you may say that the look of the specimens looks like it's a crystalline material, or it's an amorphous material, or it's probably hard or soft. No? So it's rough or smooth. No? So those are examples of a topographical information. Another information that you can derive from SEM is the morphological information. So when we say morphology, you're now describing the size and shape. So this picture is very timely in a sense that it's a fiber of a mask, used for COVID protection. So when you say describe it, it's a fiber-like structure. It's elongated. The grain size is larger or smaller. So when you use that description, you're actually pertaining to morphological information of your specimen. Another information you can get from SEM is the compositional information. Now, compositional information, such as this one, this is a layer of metals used for semiconductor. The picture here on the left is the scanning electron microscope image showing you different layers. You have copper layers, you have the plating layers, and you have the solder layers, multiple layers. And with the use of the X-ray detector called the EDS, you have the ability to be able to identify the elements that are present on the semiconductor metal alloys, and you can actually assign colors to them. Like in this case, this first layer was assigned yellow. It's actually made of copper, and the layer was colored by the software orange. It's actually nickel, and the violet is actually lead, tin, and you can mix all those informations together in one image. So that's called the compositional analysis. And by just utilizing the X-ray detector I've shown you in the image, you have the ability to do that with your scanning electron microscope. You can also use the scanning electron microscope with EDS to identify and quantify the elements that are present. You just draw a square box, or you can actually create a point, by the use of a mouse, and that square pertains to the area that the instrument would like to analyze and identify the elements that are present. And in this case, this is an example of the EDS spectra showing you the different elements that are present on the sample. So that's still a compositional analysis capability of the SEM with energy dispersive X-ray. Another capability of an SEM is for crystallographic analysis, getting the crystalline information. So the image on the left is a scanning electron microscope image. Obviously, it has sharp edges and sharp corners, which gives you an idea that the sample is crystalline. But if your SEM is equipped with electron backscatter diffractions, you can do an even more advanced analysis on crystalline information. Like in this case, now we use the electron backscatter diffractions of NASAT Labs to generate the phase analysis of the steel alloy. And I don't know if some of you are familiar with steel. Steel has many types of phases: ferrites, cementites, austenites. Understanding those phases gives you an understanding of the different mechanical properties of steel. And with the use of electron backscatter diffractions attached to the SEM, you will have the capability to be able to do the phase analysis of different metal alloys, such as these steel alloys. Another capability of an SEM is for porosity characterization. In case your SEM is equipped with a micro CT scan, then you can do this type of analysis. So maybe you're familiar with CT scan, for medical application. So you lie in bed, and then probably the doctor wants to see the inside of your brain and wants to see the CT scan image of your brain. So there is a big part of that machine that rotates and takes 360-degree image of your brain with an X-ray, and that digital image are reconstructed into a single image, using a powerful software, and that instrument generates a high resolution image of your brain. So that's called a CT scan. That's a computer aided tomography scan. The SEM also has that capability. So once you have the micro CT scan installed on your SEM, you can attach to it as part of the list of detectors. And in this particular case, they've analyzed the histogram of the alumina spheres on a polystyrene and polymethyl methacrylates. So actually, in animation view, this actually rotates, and an X-ray image is taken using using the X-ray attached to the detector, to the SEM, and takes the multiple image slices of polystyrene and polymethyl methacrylate, and reconstruct this into a single image. And then with the software, that will eventually give to the histogram information of how much, the breakdown of the diameters of alumina that's dispersed onto the polystyrene and PMMA. Now, I've shown you the different capabilities of SEM. Let me show you some of a very simple, maybe, images that you can, relate with. Human hair. So I've told you that, my hair is around 70 microns, but it depends on your age and your race. It can, the range of human hair diameter is between 30 to over 100 microns. If you simply use an ordinary microscope to image the human hair, then you won't see much of an information. But if you use a scanning electron microscope, such as this image on the right, it's actually showing you the hair follicles. And these hair follicles can, be correlated to the, properties of your hair, such as if it's damaged, maybe if it's, healthy or not. So if you are, say, developing a shampoo, or let's say if you're developing a conditioner or any hair treatment products, then you might want to see the hair. So you need to look at the human hair morphological information using the scanning electron microscope. Another image is the tea leaves. So you'll see the stomates of the tea leaves. A desiccant. So this is desiccant. When you buy new shoes, backs of the shoes contains desiccant. When you buy, you say bottles of medicine, the bottles of medicine contains desiccants. So the purpose of that desiccant is to, avoid moisture from attaching to the surface of the shoes, or attacking the packaging of your capsules, medicine capsules. And if you want to understand why a desiccant absorbs moisture, you may want to see how the desiccant looks like at high magnification image, such as this image using scanning electron microscope. This is an image of a recycled paper. So you'll see the pulp that are pressed together using the pressing machine, and you'll see how it looks like on a larger magnification. So this is an image of leaves taken from our garden outside of our lab. So you'll see these leaves actually is like contains lots of soft fibers. And if you want to understand why it's actually soft, then you may need to look at it at high magnification image using an SEM. So this is another leaves from our garden. So you see the different stomates. You know that stomates are important, the density of stomates per area, because these are responsible for photosynthesis process. So this is an image of a mosquito, part of that mosquito. And this is a mosquito from Davao when I held a training at the Ateneo de Davao University. So it bit me. So I took an image of this mosquito using their scanning electron microscope. So this is an image of the flea. Actually came from RITM in Alabang. So we're curious why the flea attaches to the skin of the animal so strong. And one thing we saw is that the claw contains minute claws, many minute claws, and these claws, help these flea to attach to the skin. So this is an image of the ballpoint pen. So it's like a very small, uh, you know, uh, deodorant. So the ball rotates, and the ball is responsible for transporting the ink from the pen to the paper. So this is a scanning electron microscope image of a damaged cell because of coronavirus. It was released in Los Angeles Times. So you see the multi-pronged tentacles of the cells was actually fully damaged by the virus, and it gives an idea of how damaging the virus really is. So this is an example of a kidney stone image. It was released by Medical University Life. So you'll see the very sharp edges of kidney stone. So just by the look of it, you'll get an idea of why the presence of kidney stones is so painful. If you like, foods with a lot of salts, too much preservative, be careful about you don't drink too much. You don't drink so plenty of water. Then be careful about the developing the kidney stones. And for your information, there are many people, and their numbers are increasing. They're going into dialysis, and a lot of people working for call centers, they already have some damaged kidneys, and they're regularly going into dialysis. So avoid eating too much food with a lot of salt and too much preservative. So you may end up to be having kidney stones and eventually a damaged kidney. So this is a colored scanning electron microscope image. The original image is monochromatic, meaning just black and white. But a software, what digital software is used to color for representation or presentation purposes. So this is the particle of a fabric softener, and this is of course responsible for how the fabric softener does its functions. Now I'm done with the SEM, and let me talk briefly about the atomic force microscope, which we also have at our facility at Muntinlupa in NASAT Labs. So AFM, atomic force microscope, is also known as the scanning force microscopy. If optical microscope is using light, if acoustic microscope is using ultrasonic sound waves, if X-ray is using X-ray, and scanning electron microscope is using an electron, an atomic force microscope is using a mechanical probe to measure the force. And that force is converted eventually into a digital image. So this type of microscope is using force measurement. AFM or SEFM, scanning force microscopy, is a part of a family called scanning probe microscope. And the reason it's called scanning probe microscope is because it uses a mechanical probe called cantilever. In fact, this cantilever is part of our logo, NASAT logo. So you'll see the white white drawing here. So that represents a cantilever. So And AFM is one of the most popular tool for nanotechnology characterization. So going back, it uses a mechanical probe that scans through the surface of the sample, and this force that's measured by the probe is converted into a digital image, such as this topographical image of the surface of the sample. There are many varieties of AFM, that you can choose from. I borrowed this image from Hitachi, one of the popular instrument for AFM. So they have a basic model. This basic model is typically enough for uh, typical nanotechnology characterizations. Or you can opt to use a vacuum type AFM in case you wanted to analyze the topographical informations at different temperature from cold to hot. So you use a vacuum AFM. Now, I mentioned that AFM is part of a family of scanning probe microscope or SPM. So, what are the other members of the family? One is the scanning tunneling microscope. Scanning tunneling microscope, it won, the inventor of scanning tunneling microscope won a Nobel Prize in Physics in 1980s. I think it's a German and Swedish national who works for Bell Laboratories of Nokia, and they developed the scanning tunneling microscopes. The disadvantage of scanning tunneling microscope is that it can only be used for conductive or semiconductive specimen. But atomic force microscope can be used for any type of specimen, whether conductive or non-conductive. So whether polymer or metal, you can also use it for liquid specimens. So that's how powerful atomic force microscopy is. Another member of the family is magnetic force microscopy, friction force microscopy. So if you want to develop coatings, so you can measure frictions once the applications of coatings is done. You can also use AFM for scanning capacitance microscopy. Wanted to analyze or research about graphene. Force distance for hardness, softness, electrostatic force, Kelvin force, and many other members of the scanning probe microscope family. But let me concentrate on AFM for limited time, no? Just a limited time. So, the one of the very first modes of AFM is called the contact AFM. So, in this mode of AFM, is that the mechanical probe called cantilever is directly attaching to the surface of the sample. As the cantilever attaches to the sample, it causes the cantilever to bend, and that bending of cantilever is translated into an image by the imaging software. Another mode of AFM is called non-contact AFM or dynamic force microscopy. Because if we go back to the contact AFM, what if my sample is soft? What if my sample is fibers or fiber likes? So you will have a tendency to contaminate the probe tip, or it will have a tendency to cause the probe tip to blunt after several times of scanning. So they developed the dynamic force microscopy or non-contact AFM. So in this mode, the cantilever, the probe, is made to vibrate at certain oscillation frequency. And that cantilever doesn't get in contact directly to the sample surface, but made closer to the sample surface. As the cantilever gets closer to the sample surface, the oscillation frequency changes. And that amount of oscillation is eventually translated into an image of your specimen. So this mode of AFM is, gives the ability to image a soft sample, samples that are, with fibers, and avoids blunting of the probe tip. But of course, uh, it's not always possible to do a non-contact mode or DFM mode every time. So there is certain applications to contact mode and certain applications for non-contact mode. So both of them are useful to atomic force microscopy. So I'm showing you another example of AFM image. This time it uses a vacuum AFM, and it analyzes the phase image of rubber tires at different temperature. So that means the stage of where the sample is placed is intentionally cooled and heated. And as the sample is cooled and heated, the phase image or topographical image is changing, and if you use a type of AFM that has no capability to cool it or heat the specimen, then this type of phase image may not be able to, it's not possible to be analyzed. So rubber tires is, one example of, you know, uh, a material that's useful to a vacuum type AFM because the phase image of the rubber tires changes with temperature. So another, example of output of SEM, but this time in tandem with AFM, is the graphene. So the picture on the left is an scanning electron microscope image, but the picture on the right is AFM image with method is called the scanning atomic and electron microscopy. So it's a kind of instrument that has capability to in situ analyze the samples in both SEM and AFM. So when we say in situ, we can actually analyze exact locations of the sample in both AFM and SEM. So another image here is a magnetic force microscope image of specimen with magnetic domains. So the picture on the left is the scanning electron microscope image, and the picture on the middle and the right is a MFM image. It tells you that certain parts of the specimen has magnetic properties and certain parts of the specimen has no magnetic properties. And the only way to observe it is by the use of the atomic force microscope with the magnetic force microscopy mode. That kind of information is not possible with SEM. So in summary, nanotechnology is a key area of growth across many industries, whether it be semiconductor, electronics, chemical industry, pharmaceutical, medicines. It's a key growth, with the value of billions and billions of dollars and expected maturity of 2081. Opportunities in this area will continue for decades. So if you align your career to nanotechnology, then there will be bright opportunity for you. The good thing about nanotechnology is that it's multidisciplinary. It's not specific to chemistry, it's not specific to chemical engineering or material science. It can also be applicable for mechanical engineers, for electrical engineers. So it's a multidisciplinary technology. Advanced characterization tools to support the technology is available even in the Philippines. Yes, we may be still lacking at certain parts of the country, like maybe in but there's already nanotechnology laboratory in Mindanao. Some universities in Mindanao already have that capability. Also in Visayas, there are already nanotechnology laboratories in Visayas, in Luzon. So many parts of the country are now slowly equipping themselves with the required capabilities to support the technology. Business sectors, government, academe are setting up capabilities to align to nanotechnology research. NASAT Labs has a facility in the Philippines to support any one of you who wants to engage in nanotechnology. All you have to do is contact us, contact FilSciHubs, and both of us may be able to help you with your research on nanotechnology. Okay, so that's the end of my presentation. Thank you very much. I'm now welcoming question and answers.
All right. Thank you, Engineer Liana, for that talk. Actually, marami po tayong questions from the Zoom chat box. I will give some of those. So, ito po yung pinakaunang question. So, meron po nagtanong, nanotech R&D is in the hands of highly industrialized countries. Philippines is a developing country. What particular subject that the Philippines can afford to do research and develop by applying nanotech?
Well, it may be true that we are a developing country, but it doesn't mean that we are not, we are not into nanotechnology. As I mentioned, even in even the Dr. Jovi of Central Luzon, for example, have created a product, that's applicable for both agriculture and cosmetic and COVID preventions. And so even as a developing nations, we can already begin participating in nanotechnology research. And you may not be aware, but agencies of the government, like the Department of Science and Technology, I'm telling you, they already have invested a lot of money in nanotechnology research. All you have to do is be familiar of the places and locations of where these instruments to support nanotechnology is installed, so that we can all of us in the Philippines can support your research. And it doesn't stop from there. Um, I've been a co-speaker with one person from University of the Philippines, and he mentioned that Philippines has a lot of money in terms of supporting research, including nanotechnology. The only concern is that not many ones are giving out proposals. So the ending is the funds that were given by the government is returned to the national government. So that means marami tayong pera, marami talaga tayong pera. Ang hinahanap natin ay yung mga tao na willing mag-propose ng isang useful na isang research na magagamit ng Pilipinas. But hindi po totoo na even though developing nation tayo, na wala tayong pera na pambili. Meron po tayo, meron. At yun ay bumabalik lang po talaga sa national government kasi wala po tayong takers. At kaya ito pong NASAT Labs at FilSciHub ay magandang opportunity to educate yung mga nakikinig sa atin na wag po tayong maniwala na wala po tayong resources. Meron. All you have to do is ask for it, make a proposal, a good proposal, and you will be given enough funding for your research. Thank you.
Just a follow-up lang po dun, sir. Is there any nanotech product that is already in the market that is produced locally? Meron din pong nagtanong ng ganun.
Locally, yes. Actually, dito sa let me quote, yung alam ko lang ha. Sa DOST meron silang mga tinatawag na clay products, considered nano clay, and they're developing some nanofilters. And then these nanofilters are used to filter waters, like parang pitche lang siya, pitche lang siya, tapos ilalagay mo lang yung water doon, and that cleans the water, para maging magamit siya na malinis na tubig. So isang example na ng product 'yon. Itong mga nanofertilizers, I don't know kung ito yung nabanggit ko kanina sa aking slides na si University of the Philippines Los Baños, si Central Luzon State University, they developed the nanofertilizers. Nabigyan na kami ng nanofertilizers and nagamit na namin yun sa aming garden at maganda yung resulta. Ang hindi ko lang alam kung binibenta na itong nanofertilizers sa market. Now, how about yung local companies? Nabanggit ko yung Pacific Paint. Pacific Paint, di ba? Yung Boysen, familiar naman kayo siguro sa Boysen, gumagawa sila ng pintura. Yung isang brand nila ng pintura called Knocks Out, available na yun sa market. Pwede ka nang bumili. At yung Knocks Out paint na yun, pinintura na yun doon sa part ng EDSA. No? Pinintura na yun sa part. Readily available na tong product na to, locally available. Hindi nga lang natin masasabi, pero ang Pacific Paint is a local company. No? Yung Boysen, it's also a local company. No? So kung yun ang tinatanong natin, may mga example na ba ng product? Yes, meron na. And maybe you're not aware. Alam nyo ba na yung ating itong smartphones? Alam nyo ba yung mga telepono na ginagamit nyo ngayon sa inyong mga webinar? A lot of components na nandyan ay gawa sa Pilipinas. Sa mga semiconductor ng Pilipinas, no? Taga-semicon ako dati at marami diyang product of nanotechnology. Ginagamit nyo na natin siya. Hindi nga lang tayo aware na yun pala ay nanotechnology. Ine-export lang natin yan minsan sa China para i-assemble into iPhone. Pero yung components niyan, dito yan sa Pilipinas ginagawa. No? So yun ang example ng mga produkto ng nanotechnology that maybe you are not yet aware.
Ayun, thank you sir for the explanation. And just a follow-up on that, no, kasi medyo marami po talagang questions. So
Sige.
aside from the advantages of nanotechnology, ang mga tanong po dito is what are the disadvantages of nanotechnology if there is any? And kung meron na daw pong impact assessment about nanotechnology products na produce na way before, and also with respect to nanofertilizers, meron daw po bang biohazard na nai-impose dito? Or what is yung, kumbaga, ano po yung economics, ano po ang advantages niya in terms of the yung normal na fertilizer with nanofertilizers?
Actually, magandang tanong yan, let me just share you that dito sa Technical Committee ng Nanotechnology ng Pilipinas, TC85, na pinangungunahan ng Department of Trade and Industry, meron tong tatlong subcommittee. No? Yung isa, subcommittee on material characterization. Yung isang subcommittee dito is nanosafety. Nanosafety. Bakit may special subcommittee for nanosafety? Kasi totoo naman talagang concern, yung common concern yan na baka naman mayroong safety issue yung nanotechnology. Pero ang tanong is, well-studied na ba yung mga possible safety concerns ng nanotechnology? Well, hindi pa lahat. Hindi pa lahat. No? Baka may mga technology pa na, yun nga, na-mention yun, na biohazards at maring hindi pa fully study. Ano bang effects niyan during disposal? Baka naman pumunta yan sa ating bodies of water, tapos kainin ng isda, tapos magkaroon ng mga bioaccumulations na eventually, magkakos ng mga other sicknesses. No? So yun yung mga kino-consider talaga sa subcommittee on nanosafety. But hindi pa tapos, no? Pansinin niyo yung technology paradigm. Tayo ay nandito pa lamang sa our early adoptions. Nandito pa lang tayo sa paghahanap ng mga iba't ibang research. At kino-consider talaga doon yung nanosafety. One day, kapag lahat ng iyon ay aral na, then meron na tayong mga full na answers, mga buong kasagutan sa lahat ng mga technology na may kinalaman sa safety issues or hazards ng nanotechnology. Pero hindi pa yan, wala pang answer ang lahat ng iyan. Pero yan po ay kasama na po sa kino-consider sa pagde-develop ng nanotechnology. Another question.
Nakamute pala ako. Thank you, sir. For those for the participants who want to ask their questions live, pwede po kayong mag-raise ng hand para po mas interactive yung ating meeting. So marami pa pong questions, sir. So
mahaba Haba pa naman ng oras natin hanggang 'di ba 12 pa
Oo,
'to?
baka daw po pwede kayong makapag-suggest or meron daw bang role ang nanotechnology sa construction? Sabi po nung isang civil engineer student na nandito po sa ating webinar.
Oo, sabi ko nga multidisciplinary. So ano ba ang importante sa isang construction? 'Di ba ang ano nyo is alternative material. Baka naman pwede ba tayong humanap ng isang construction material na nakakapag-absorb ng tubig para maiwasan yung baha? Meron ba tayong pwedeng gamitin na isang uri ng salamin na nagko-convert ng sunlight into usable energy, no? So part din 'yun ng construction. I don't know kung nabalitaan nyo yung isang ginawa ng yung isang mapuwa estudyante, no? Na nanalo ng Dyson Awards. Siya ay tawag nito mula lang sa crops, mula sa mga wasted crops, tapos nagko-convert na 'yon ng electrical energy, parang ginagamit natin siyang parang So ano 'yun, pwedeng gamitin construction material 'yon, no? So maraming possible na applications ang nanotechnology, no? So, but of course, ang key dito kung ikaw ay civil engineering, siguro yung mga corresponding materials na can be used as a replacement, provide ng strengthening mechanism, solution sa mga baha, mas matibay, no? Yun yung mga pwede nating i-consider sa applications to civil engineering, no? But as to kung meron akong maibibigay na sample products na ginagamit na sa civil engineer, wala akong mabigay sa iyo right away, no? So yung mga nabanggit kong products sa inyo is an idea ng applications ng nanotechnology sa civil engineering. By the way, no, mayroon pang isang I don't know kung pwede kong i-share, no? So but mayroon pang isa na yung asphalt, may hinahalo sila na isang nanoparticles doon sa asphalt, tapos tinitingnan kung yung nakakatulong ba yon sa pag-reduce ng level ng metal pollutants, no? So ihahalo lang yung particles na yun sa asphalt. Pero ang applications naman nun is more on environmental applications. Pero dahil asphalt, ginagamit naman siya for civil engineering. So pwede natin din i-consider yon na civil engineering application.
Okay, thank you, sir. By the way, let me acknowledge po yung presence ng aming CEO at ng President, si Kuya Jeff. Kakarating lang niya. Pero kanina pa siya, sir. In the middle of your talk, dumating na siya.
Hi, Jeff.
Hi, kumusta po? Kumusta po sa inyo lahat? Okay, I just got back from a week-long vacation. But I can actually make a comment, sir. So there was a question earlier about potential application of nanomaterials for civil engineering or for construction. So to the person who actually asked that specific question, in particular, like in the Chinese market, they have actually been using carbon nanotubes and carbon fibers as one of the composite materials for civil engineering applications. So like the main advantages of some of these nanomaterials is like on their durability, the strength, durability, and also like lightweight kasi itong mga materials na to. So you might actually want to check the academic literature when it comes to the application of some of these materials, but definitely there are already some markets out there, perhaps not in the Philippines, that have already been like applying nanomaterials for construction. So marami yan. Mag-Google Scholar kayo, search, you'll find some of those key applications. So I just heard that. I just heard that question, sir. So I thought perhaps I could share quite a bit. But yeah, thank you so much for your talk, sir. Like the introductory seminar that you shared with our audience. I think the attendance peaked at about 170 participants. So it's a very good introduction of nanotechnology to the entire Philippines. So thank you so much.
Welcome.
Thank you, Kuya Jeff. Sir Marlon, ito pa, may isa pang question. So, since sabi niyo po is uptrend yung nanotechnology ngayon until 2020, ano nga po pa, anong year yun? Basta may
2081.
2081. What do you think are the applications of nanotechnology in what we call Fourth Industrial Revolution, or particularly in IoT or Internet of Things?
Well, alam nyo yung Internet of Things, ano lang din yan eh. Kailangan mo yan ng mechanical device. Tama ba? So such that yung mechanical device na yon nagko-communicate. Kuwari, gusto mong kontrolin yung bintana sa bahay mo gamit ang iyong cellphone. Gusto mo, ganong klaseng ka-advance ka na. Hindi mo naman yan pwedeng kontrolin nang wala kayong connectivity, di ba? So syempre, yung bintana mo, nakakonect yan sa isang electronic device na nagko-connect sa internet. Tapos yung cellphone mo na yon magko-connect. So kailangan mo ng sort of mechanical device na may parang nagsisilbi siyang medium of communications. Now, paano mo madidevelop yung mechanical device na yon? Kailangan mo ng nanotechnology. So more features, gaya nga ng example ko, no? Of course, ang cellphone, mobile phones, nakikita lang natin siya as mobile phones. Nakikita lang natin siya as may software, may apps, may games. Pero hindi po yan magpa-functions completely. Kung wala po talaga yan, particular hardware na na magsusupport dun sa software na yun. So, syempre, kapag mayroon siyang multiple capability, kailangan paliliitin mo yon para multifunction siya. No? So, doon magsisimula ang sinasabi niyong fourth generation, yung Internet of Things. Kailan mag-develop muna tayo ng corresponding hardware to support yung technology. At yung hardware na yon, sinisigurado ko sa inyo, ay nanotechnology developed yun.
Yan, tama. Tama po yun, sir. So, isa din po sa importance niyan sa IoT siguro yung halimbawa sa mga more powerful chips na medyo maliliit na talaga siya.
Tama.
Yung na ginagamit po natin sa mga gadgets and kunwari laptops and cellphones para po mas mabilis yung performance nila.
Tama. So hindi lang yun puro software, no? So hindi lang yun puro software. Kailangan talaga natin doon ng hardware para complete natin yung Internet of Things.
Yan. So, any more questions from the floor? Meron pa ba tayong... Ayan, meron pa. Sabi dito ay, Sir, meron daw po bang technology para ma-view ang, like say for example, instruments para ma-view ang moving atoms like protons? Siguro po high school po ang nagtanong nito. Protons, electrons, etc.
Wala yung makikita mo talaga na gumagalaw yung mismong protons and
yes, yung electrons kunwari po gumagalaw. Yeah.
Actually wala pa akong alam, although I don't know kung narinig nyo yung sa CERN, yung technology ng CERN. Yung yun parang isang napakalaking accelerator dito sa Switzerland, yung CERN. I-search nyo po yung CERN, CERN. So, kinonstruct nila yon para sa isang tinatawag na Higgs boson experiment. Yung Higgs boson ay isang particle na tinitingnan sa loob ng nucleus. Yun yung pinaka-high-tech na meron. Pero kung gusto talaga natin makita kung paano ba, may sungay ba yung electrons, paano siya gumagalaw, wala pang ganong klaseng technology, no? Kasi tayo ay nandito pa nga lang po tayo sa nanotechnology, no? Nano, 10 to the negative 9. Ito pong mga particles po na sinasabi nyo, yung electrons po, nasa 10 to the negative 12 po yan. So, ibig sabihin, kung gusto natin talaga physically makita yon, hindi pa po ganun yung level. Nandito pa lang po tayo sa 10 to the negative 9. No? Yun po ay 10 to the negative 12. Ang pwede natin siyang makita is like, gagamit tayo for example ng isang instrument na makikita natin yung behavior ng electrons pag nag-apply tayo ng current. Pero kung yung ini-imagine, hindi ko alam kung parehas tayo ng ini-imagine ko yung tanong nyo kung ang tinatanong ba is makikita natin kung paano ang itsura ng electrons, gumagalaw, sumasayaw ba siya, ano ba yung shape. Ayun, hindi pa natin siya, wala pang ganong klaseng instrumento. Pero yon, pwede mo siyang ma-visualize gamit ang mga software. No? Kung paano yung probability, di ba, yung sa mga electrons, no? Nagagawa yun ng software. Pero hindi yun talaga direct observation sa kanila. No? Hindi siya direct observation. Nakuha niyo po yung answer ko? So tayo ay 10 to the negative 9 pa lang. Wala pa tayong 10 to the negative 12 technology na mabivisualize natin yung ganong klaseng particles kung ano talaga ang itsura nila. No? Pero pwede mo yun magawa sa software. Masa-simulate kung ano yung nagiging behavior nila.
Yeah. Thank you, sir. Ito naman po medyo interesting. Yes po.
I actually just wanna add to it. You know, if it's a high school student or teacher who asked about that, so yun po ating quantum concepts and about yung duality of properties of these subatomic particles. You know, they exist like, you know, simultaneously as a particle and as a wave. So if the idea po is to visualize the movement of electrons, that is actually not available as of yet. Even if you actually go to accelerators, such as that one established by CERN, everything that we know of these subatomic particles are based on models and also based on spectroscopic data. So there's really no direct observation of any of these subatomic particles. So it'll take time. I mean, the only chance for us to be able to see an electron is kung if freeze niyo po yan to absolute zero, wala nang vibration whatsoever ang matter. So pero I don't think that's achievable anytime right now or anytime soon. So yun po.
Sobrang tagal pa nun.
Fundamental chemistry, fundamental physics po, medyo mahirap po talaga siya. Or sobrang hirap, not medyo.
Yeah, pag absolute zero na yung usapan, mahirap talaga siyang ma-achieve. Anyway, actually, sir, ang dami po talagang questions like iba't ibang field. Parang gusto nila magkaroon tayo ng mga example for every field. Pero this one is more specific. Sir, meron daw po ba kayong alam na in nanomedicine na na-apply ang nanotechnology for retroviruses like HIV, specifically like regarding their viral genome alteration or maybe suppression of this retroviruses using nanotechnology?
Alam mo, kailangan na natin ng specialist on medicine pag ganung level na yung pinaka-answer. No? Pero all I can say is that yung nanotechnology is a parang it's a technology talaga for nanomedicine. Like one example is in drug delivery. Like they're developing using nanotechnology to deliver a specific drugs to specific types of cells, to cancer cells. Pero kung tatanungin niyo ako, for example, na halimbawa to cure HIV, paano ba in-apply doon yung nanotechnology? Siguro kailangan na natin doon ng person specializing on that. So all I can tell you is that definitely nanotechnology ang applications niyan. Like sa coronavirus na lang, wag na tayong lumayo, no? Ang dimensions ng coronavirus is 7,500 nanometers. Paano mo ma-observe yung tentacles niya? Paano mo ma-explain yung mechanism kung paano siya patayin or ma-deactivate, paano patayin yung isang cell ng isang coronavirus, no? So kailangan mong kailangan mong masilip yan. So sinisilip mo yan sa TEMs, no? So ang nakikita natin, syempre itetest ka na sa vaccine, pero bago itest na yung tao sa vaccine, mga ganong klaseng trial na. Pero sa laboratory, ginagawa yon, no? So kailangan masilip mo muna kung anong itsura ng virus, tapos i-expose mo muna yung virus dun sa vaccine, tapos isilipin mo din yung virus dun ulit sa SEM after ma-expose sa virus. Kaya ako nasabi yan kasi meron po kaming isang client pero hindi coronavirus, sorry, ASF naman, no? Yung virus ng ASF, around 40 to 75 nanometers naman yung size. Meron siyang dinidevelop na vaccine. So ang nangyari, yung vaccine na yon, in-expose lang niya doon yung ASF, tapos sinisilip namin sa scanning electron microscope yung influence ng vaccine doon sa virus. Hanggang ganun yung level na kaya ko. No? But definitely, merong application yan sa nanomedicine, like drug delivery. Hindi ko lang alam particularly kung mga HIV, rhinovirus, mga ganun. Hindi ko sure.
Yeah, I could actually recommend a professor's name in UP Diliman po. She's doing nano material synthesis, so more particularly metal sulfide chemistry. So her name is Michelle Regolacio. So she recently moved to UP Diliman from A-Star in Singapore po. And so what she's actually doing is she's developing these metal sulfide nano materials, and they're actually at least evaluating them for drug delivery. So essentially, yung mga sulfur-containing enzymes, they're trying to mimic them, and then use some of those molybdenum sulfide nanomaterials or nanomoieties to mimic some of those active sites. So meron po sila mga cell testing din. So if you're interested in learning more about like local studies going on in the Philippines in this area, and for potential collaboration and mentorship po, we do have some experts. So Michelle Regolacio, she's actually our local expert in the Philippines.
Yes, agree ako dyan. So, sabi ng katulad ng sinabi ng dalawang sir, si Sir Liana and si Dr. Jeff, yung nanomaterials are actually very important for drug delivery because pwede mo siyang i-adjust para maging compatible dun sa cell or para mas ma-absorb ng cell. Likewise, for medicine, pwede rin natin gamitin yung nanotechnology para mag-improve yung interaction between the cell and also dun sa medicine natin. So marami talagang applications ang nanotechnology when it comes to medicine. So actually yung ibang questions hindi ko na kina-call out ko na kasi yung iba parang ano lang ng parang ideas because pwede mo naman kasi itong i-search sa internet yung iba pero ito sir, chance nyo na rin po para i-promote yung NASAT. Marami pong nag-question dito kung ano daw po yung contact information nyo kasi gumagawa daw po sila ng research for nanotechnology and who to contact, what's your contact information, email, number, lahat-lahat na po ay i-plug na po natin.
Sige, since binigyan mo na ako ng authority kasi syempre baka bawal, no? Pwede nyo po kami, meron din po kaming Facebook page, NASAT Labs. Kahit doon na lang po kayo magsimula, tapos mag-message lang po kayo doon sa aming Facebook page. Tapos may sasagot naman po doon na customer care. Kung hindi naman, pwede nyo rin pong i-visit yung aming website, www.nasatlabs.com. No? So, o kaya i-google nyo lang yung NASAT Labs, mapupunta na po kayo doon sa link. So sigurado naman po na makukontak nyo po kami. Tapos kung ano man yung particular questions nyo like cellphone numbers, pwede na natin doon maibigay. No? So yan, pwede nyo kaming i-like, i-follow yung aming Facebook page or message us doon sa aming website.
Ayan. So, thank you, sir. Meron pa pong last question dito. Sir, nagpa-provide daw po ba ang NASAT ng virtual educational tour para sa mga students na gustong makakita ng isang actual lab for nanotechnology?
Opo, yes na yes. In fact, ngayong December, meron po kaming ilalabas na isang event ng virtual lab tour. Uunahin lang po namin yung ang nakaplat ngayong December, 1.5 hours for scanning electron microscope. Magraran tayo doon ng actual sample. Makikita nyo kung paano ba mula doon sa sample na yon, paano siya ipasok, i-run, i-operate. Tapos anong magkalalabasan niya na image doon sa SEM. No? So this coming December yon, inaayos pa namin yung aming yung poster. Pero lalabas na yan in the coming days. Baka next week lumabas na yung poster niyan. So para hindi nyo ma-miss yung opportunity na yan. Dahil ito po ay wala pong bayad. Tandaan nyo po yung para po sa mga nasa industry, kami po talaga ay naniningil ng corresponding payment kasi kailangan naman namin mabuhay. Pero para po sa mga support po sa STEM education, may naglalabas po kami ng mga certain events na free of charge. Kaya kung ipa-follow nyo po yung aming Facebook page, hindi nyo po mamimiss yung opportunity na yon na maka-attend. So ngayong December, baka next week lalabas na po yung poster ng virtual lab tour. Virtual, may tawag kami doon virtual, basta magra-run kami ng SEM live. Tapos meron pang mga susunod na mga instruments. No? Ngayon, kung kayo naman po ay belonging sa isang academic institution, ginagawa na po namin yan sa bawat university bilang tulong. No? Nagawa na po namin yan sa UP Diliman, nagawa na po namin yan sa UPLB, nagawa na po namin yan sa De La Salle, Lipa, nagawa na po namin yan sa Mapua University. No? Gusto ko naman sana, magawa ko naman to sa iba pang mga eskwelahan na hindi na yung mga popular schools na yon. No? Gusto namin ibahagi yung aming capability and resources sa lahat po ng university sa buong Pilipinas. Iniintay lang po namin talaga kayo na kayo ang kumontak sa amin. Kasi kaysa yung kami yung lalapit po sa inyo. So just send us a message. We will organize a virtual lab tour bawat school. I-schedule lang po natin yan kasi napakadami pong eskwelahan sa buong Pilipinas. I-schedule lang natin. But to begin with, kailangan nyo po kaming i-message. And then mapag-uusapan po natin yung arrangement na iyon.
Ayan, thank you. Thank you, sir. Mukhang aabangan niyo ng mga teachers natin, pati mga students, kasi excited sila na makakita ng isang real lab for nanotechnology. Actually, maraming students ang nagtanong niyan kung meron bang virtual lab tour. And also, sir, ano po bang mga requirements niyo for collaboration for SUCs? Meron po kasi ako nakita SUCs and other colleges na gusto po makipag-partner sa inyo kasi may nakita po akong question na ganun sa YouTube po natin.
Okay. Hindi ko kasi alam kung una is dapat meron kaming capability, no? Kasi kahit na kami po ay nanolab, hindi lahat ng instruments meron din kami, no? So hindi ko alam kasi kung anong research area meron ang particular SUC na binabanggit natin, no? Although meron na kasi kaming existing collaboration sa ibang mga school, no? May state university din. So kung halimbawa nagtutugma yung capability na meron naman yung NASAT at saka yung interested research ng SUC, pwede namin mapag-usapan. Like for example, research po sila na nangangailangan ng paggamit ng thermal analysis instrument kasi wala po sila noon. Or gagamit sila ng ICP-OES or EAS kasi wala sila noon. Or SCM kasi wala sila noon. Mapag-uusapan po namin yon. Ang typical requirements, ano bang requirements is number one, mas maganda sana kung ito ay supported din ng inyong academic, yung school mismo, no? Kasi hindi naman palagi, may goal kami na suportahan yung buong university sa buong Pilipinas. To tell you honestly, kung ganun ang gagawin namin, wala kaming pangkain, alam mo yun. So may gastos din kasi yung consumables. Pero hindi kami gumagawa ng profit para doon sa mga SUC. So kailangan lang po natin na i-contact nyo kami, then we will lay out yung need and how we can support you na hindi nyo naman iisipin na we are making huge profit or profit from all of you. No? I-start po natin yung conversation properly kung meron kaming capability sa particular need niyo po. Magpapatuloy po yung ating collaboration. Just send us a message, no? I don't know, maybe kung kaya nyo pong i-record ang aming pong email address po ng customer care namin is customercare@nasatcorp.com. Madali lang po tandaan, customercare@nasatcorp.com. Or kung hindi nyo po maisulat, just visit our Facebook page.
Ayan, thank you sir. So with that,
Ako po.
we are concluding this seminar. So maraming salamat po sa NASAT Lab and kay Engineer Liana. So we will issue an e-certificate po, nakalagay na po dyan yung Google form where you can get your e-certificate. But before we let you go, gusto ko lang pong tawagin ulit si Kuya Jeff for future events ng FilSciHub.
Okay. Thank you so much, Marty. Maraming salamat po ulit. I'm Engineer Liana and Jasmine for making this possible and for sharing your knowledge with our fellow Filipino STEM educators and teachers. So muli po sa ating po mga nag-participate, maraming salamat po sa inyo. Ang dami po nangyayari sa atin sa Pilipinas ngayon. Kami po, karamihan po sa amin sa FilSciHub ay nasa ibang bansa. Ako po yung nasa Houston ngayon. So, on behalf of the entire FilSciHub team. So, mag-ingat po sana kayo dyan palagi. And, if there are things that we could be of help with, as you tackle this new normal in the Philippine educational sector. So, please let us know. Ito pong webinar na kakatapos lang po natin is a special topic in nanotechnology, and our main intention is to introduce some of these up and coming areas of technology sa inyo po. And nanotechnology is actually one of the most important and I think the most current areas that we believe the Philippines should be very familiar with. So ngayon po, kilala nyo na po yung NASAT. If you come across with any of your colleagues na medyo nangangailangan po siguro ng tulong sa nanotechnology, we do have our local experts like Engineer Liana to reach out to. So gamitin po ninyo yung mga local resources natin. And then again, at the same time po, ito naman po FilSciHub. So this special topic is part of FilSciHub's Research University. So ang goal po namin talaga dyan is to mentor our Filipino teachers and students in the STEM area when it comes to science research. So from the ideation stage all the way up to experimentation and also science communication. So ano po ba ang aasahan ninyo? So meron pa po itong mga kasunod na session. So yung pong aming Research University courses ay dalawa na ang aming natapos. So the first of which was on ideation. The second was on literature review or search. So ang kasunod naman po niyan is on experimentation. So please expect for us to schedule something sometime in December or January, and it's a special course on how to design an experiment. So yun po, pinaghahandaan po namin yan. So just keep checking our official Facebook page and also our official website for some of these updates po. And then sa amin pong website, there's an RSS subscription. So pwede po kayong mag-subscribe doon, sign up nyo po inyong email. So every once in a while we send out newsletters po if we have some of these special course offerings. And we can contact you directly po para alam niyo kung kailan yung third lecture namin on experimental design. So yun po. We hope that you guys are safe sa sa lahat ng mga nangyayari, and then if you have questions, as usual po, reach out to us through email and also through our Facebook page. So marami pong paraan para po maabot ninyo kami. So hindi marami po itong kasunod. Ang amin po talagang target sa Research University is to finish or is to give you lectures and courses all the way up to the last step of doing science research. And then we have a big goal that next year po hopefully we can hold a virtual or a virtual science conference sa lahat po nagpa-participate, and to build a community po, not just with students and teachers at the high school level, but we're also starting to recruit Filipino and also foreign national scientists po that can help mentor you. So we've been doing some work in the background, so please watch out for those things. Maraming salamat po. So we don't really want to occupy your lunchtime. So Marty, maraming salamat, and then everyone else from the FilSciHub team for running the show. I thought I wouldn't be able to make it on time for this webinar, but nakahabol po. So muli, maraming salamat po. It's always a pleasure.
All right. Thank you po. And again, thank you to Engineer Liana and kay Jazz and also sa NASAT Lab for this webinar. And if you missed the first two parts of the Research University webinars, you can always go to our YouTube channel, that's FilSciHub, and also sa amin pong website. Nandun po naka-upload lahat ang aming mga webinars about Research University. And of course, this talk will also be uploaded on our website. So any last parting words before we go, Engineer Liana, for our participants?
Lagi kong sinasabi with STEM, you can never go wrong. No? So if the governments, business sectors will start to invest in and provide resources to STEM educations, they can never go wrong. But you as a student and professor, if you align, since you're already in STEM, I'm sure that you made the right choice. Now, STEM is so big, and I'm a proponent of nanotechnology. And I always hold on to the technology paradigms that were released by experts. Nanotechnology will go a long, long way. It will eventually be part of our daily lives, even now and in the future. So if you align yourselves, your career to this area, I imagine a bright future for all of you and a bright future for all of us. And if you are a person that really is into science research, there is resources provided by the government. We have money. All you need to do is learn how to make a proposal and how to, learn how to win and into an approved proposal every time. So I think you just need to attend many scientific conventions such as this one. Marami namang mga maraming mga events, hindi lang pinoprovide ng FilSciHub, pati ng mismong government, para maging aware po tayo sa mga science and mga opportunities in science. No? At kung pagpapatuloy lang natin yon, I think one day you'll bump into the right opportunity and help the country progress through science and technology. Thank you very much.
Thank you po. And again, thank you sa ating almost 150 participants, combined YouTube and Zoom participants. Maraming salamat po for joining us. And with that, we will conclude this webinar. Abangan nyo na lang po yung mga susunod na offerings ng FilSciHub. And thank you so much. Have a happy lunch.
Okay.
Thank you po.
Welcome to FilSciHub Research University, your ultimate guide on your next research project.
We will lay down the best practices in research ideation, literature review, experimental design, and data analysis to guide you as you carry out your research project. Learn from the FilSciHub team of research scientists and some invited subject matter experts. FilSciHub Research University will be your personal coach through every stage of your research project, from ideation to final assessment.
And the best part, it's absolutely free.
Visit us at FilSciHub.com and be part of this learning journey.
Let's learn and succeed together here at FilSciHub Research University.